Hello, welcome back to my YouTube channel with me, Christarmy Manus, from Information Systems Class A 2023. Right now, I'm going to tell the summary presentation of Icon Smart by Professor Negami. The focus of the Icon Smart 2023 International Conference on Natural Sciences Mathematics Applications Research Tech. The conference aims to address the changing forms of education, research, and industries in the midst of the COVID-19 pandemic. It emphasizes the need for better modeling, bioinformatics, and material science in various sectors such as medical, food, and marine industries. The conference has seen participation from renowned speakers and institutions from around the world, promoting collaboration and sharing of knowledge. This year, the conference is being held in a hybrid format at Samratulangi University in Manado, Indonesia, with a focus on data optimization for instrumentation, physics, food security, and energy sustainability. The moderator, Mr. Windra Swastika, welcomes the distinguished guests and participants from various countries. He introduces the first keynote speaker, Professor Seiya Negami, who is well known for his work in the field of topological theory. Professor Seiya Negami will be discussing the topic of GRA coverings and their applications, highlighting the elegance of mathematical structures and their practical implications. Professor Negami begins his presentation on graph covering and its applications. He starts by thanking Professor Shikata and others for their support and mentions that he is a mathematician who prefers pure mathematics. However, he acknowledges that he is working on applications due to the budget provided by Professor Shikata. He then gives an analogy using 5 dishes to explain the concept of graph covering, emphasizing the correspondence between numbers. He concludes by stating that graph covering is a complex mathematical concept that not many people understand, but it is essential for certain applications. Professor Negami discusses the concept of cover graphs and how they can be used to create a large network from a small one. They explain that coverings can be used to create a big cycle that covers smaller triangles, and that by studying these coverings, rapid algorithms can be developed to analyze large networks. Professor Negami also introduces their own work in topological graph theory and how they found inspiration in creating new subjects. They mention the idea of finite planal coverings and explain that if a non-connected graph has such a covering, it can be embedded on a projected plane. They use the example of eliminating unexpected crossings in a circuit to illustrate this concept. They conclude by mentioning their retirement and their focus on deep thinking and writing papers, wondering about the application of AI in their work. Professor Negami discusses their unexpected encounter with AI during a conference on natural sciences. They had asked the AI about its thoughts on using AI as the theme of the conference, but the AI replied that it didn't know their specific conjecture. However, Professor Negami believes that AI creations are rooted in past knowledge, while researchers create new knowledge for the future. They also mention their work on papers related to their conjecture and explain the concept of composite covering using graph theory. Additionally, they touch upon the idea of NP-complete questions and their complexity. The challenge of solving NP-complete problems using both classical and quantum computers. They mention an inspiration they had about using spanning trees to recognize and construct exponentially many coverings of a graph. Professor Negami goes on to explain how they developed a cryptography system based on this idea, where the sender can encode a message using a spanning tree and the recipient can decode it by finding the spanning tree. They also mention the abbreviation MAH, which stands for mathematics, and how they added 3CS to the existing discipline. Overall, Professor Negami describes their journey of developing a system that belongs in the field of mathematics. Professor Negami discusses the importance of mathematics, specifically graph theory, in solving problems. He mentions that not everyone can deeply understand graph theory, so mathematicians are needed to find solutions. One participant asks about the challenging aspects of working with irregular graph coverings compared to regular ones. Professor Negami explains that in Japan, typhoons are a frequent occurrence, and he gives an example of how even numbers of typhoons can exist while odd numbers cannot, which is a conclusion drawn from topology. The participant also asks for practical examples or case studies where graph covering concepts have been used to solve significant problems or optimize processes. Professor Negami admits that this is the first time he has applied his mathematics for practical purposes and does not have any case studies to share. He concludes by highlighting the importance of mathematicians in solving research problems.